Hello, in this algebra video, I'd like to walk you through how to factor binomials. Now, in a previous video, I walked through how to memorize these important patterns. I'll say that the first step to factoring binomials is, in fact, to know these three important patterns. If you don't know these patterns, then that's where you need to start. If you are good at memorizing, if that comes somewhat easy to you, then start by memorizing them. If you need a little help with memorizing these patterns, then maybe go back one video previous and watch the video on how to memorize these. What we want to do is be able to factor things like what you see, this numbers 1 through 8 written here. These are all examples of binomials. None of these have a greatest common factor, and we're going to try to factor these with these patterns. Here's some steps that you can use to factor a binomial with a pattern. The first step is to write the terms as a square or a cube. Once you've written the terms as a square or a cube, you need to pick which of these patterns you're going to use. Is it the difference of two squares, or is it the sum or difference of two cubes? So after you write the terms either as two perfect squares or two perfect cubes, decide which of the three patterns your binomial falls into. That's the second step here. And once you decide which one it is, you want to actually write that pattern out. Third step, name the A and the B. That's it. You need to write it out. I know you might look at this thinking, there's got to be an easier way, and there is. Some students can jump from the question all the way to the answer, and if that's you, then you should go forward doing that. But I'll tell you, if you have any struggle at all, instead of saying, I just can't do this. This is too hard for me. I can't, I'm telling you, you can do this in these 5 steps. Not one of these steps is challenging. Each step, just one at a time, you can do this. So the first step, write the terms as a perfect square or perfect cube. Second step, pick which of the 3 patterns it fits. Third step, go to your parentheses above in step 1 and pull out the A and B and actually write it down. A equals blank, B equals blank. And then fill in that A and B. And in some cases, after you fill in A and B, you'll need to simplify. So are you ready to try an example? Let's look at this example 1, x squared minus y squared. Well, the first step is really already done for us here for this one, right? The square terms are x squared and y squared. There's nothing fancy to do there. The second step, writing the pattern, a squared minus b squared, since it's a difference and it's 2 perfect squares, not cubes, then the pattern we'll use is this first one. A squared minus b squared equals a minus b times a plus b. I can't emphasize enough how helpful I think it will be to you if you actually write these steps out until you get really comfortable with it. Now, this next step is to pull out the A. In this case, A is x, A equals x, and pull out the y. The y is the b. So you pull each of those terms out and actually name them. Actually write them down. Write A equals x and write b equals y. Now all that's left to do is replace the a's. Let me turn the highlighter on. These 2 a's are going to be replaced with x. It'll look like this. And the 2 b's are replaced with y. That's it. That's all there is to it. and that is the factored form. So you see x squared minus y squared using the special pattern. Factors to x plus y times x minus y. Let's try one that has just a little bit more challenge to it. This x squared minus 100. First step is to write the terms as, in this case, perfect squares. So we're going to write x squared, it's already done, is an x squared. 100. What I'm doing here is I'm thinking off to the side, what is the square root of 100? Or in other words, what number do I multiply by itself to get 100? The square root of 100 is 10. So in this case, the A is going to be x and the B is going to be 10. Well, let's go back a step and write the pattern. The pattern we're going to use, first we've got to choose which pattern to use, but since this is a square, it's going to be this first pattern, right? So a squared minus b squared is equal to a plus b times a minus b. Are you okay with that switch? Do you see how I have it typed here, a minus b times a plus b, but do you see how it's equivalent if I change it to plus and then minus? That's because multiplication is commutative, so I can change the order that I multiply and it doesn't change the result, the product when we multiply. Then I've already written out that a is x and b is 10 in this pattern. So now in this pattern, I'm going to replace the a with x and replace the b with 10, and that's it. X squared minus 100 factors as x plus 10, x minus 10. Let's try another example, number 3. Here we have x cubed minus y cubed, number 3. So we have an x and a y again. So I'm going to write the pattern. I'm going to choose this a cubed minus b cubed. If you're wondering, why did I choose that pattern? I chose this pattern, the a cubed minus b cubed, because 1, we have 2 cubes, and 2, it's a difference, a subtraction. So that's why I choose the a cubed minus b cubed. Now I'm going to write that pattern out. I know we just wrote it, but we'll write it each time until we get really familiar with it. A minus b, a squared plus ab plus b squared. The signs are the same, opposite, and always positive. So what was a for this example? A was equal to x. And what was y for this example, or b rather, I'm sorry. A is replaced with x, and b is replaced with y. Now, watch what's going to happen here. This is a little bit different. I could start by filling in these plus and minuses. So I'm going to have the same sign, opposite sign, always positive. But watch what happens when I go in to replace the x's. Do you see what I've done here in the second factor? Is I've put in for a squared, ab and b squared, I've put in empty parentheses, and I'm going to write in that this is a squared, and then we've got the ab and b squared, right? Now a is x, so everywhere in our pattern that we have an a, I'm going to fill those in with x, x, x. And then everywhere that I have a b, 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 I'm going to fill in with a b. B, or I'm sorry, not b. Getting carried away here. This is so much fun. I meant to say fill it in with a y, right? I'm replacing the b with a y. So y, y, y. Every place that I had a b in my pattern, those three b's, get replaced with y. And that's almost it. It's just that sometimes I could have a little simplifying to do. Now this one doesn't have anything that simplifies, but I could get rid of those extra parentheses. They were nice training wheels to make sure I got everything in place, but I could write the final answer as x minus y, x squared plus xy plus y squared, and that's the finished factoring. Let's try this next one, x cubed minus 8 cubed. I could start by writing the terms as 2 cubed, so we have an x cubed and we have a 2 cubed. Now where does that 2 come from? I made a note over here to demonstrate where that 2 comes from. What we're doing is we're taking this 8 and cube rooting it, because what we're looking for to fill this in with is what can multiply by itself 3 times to give us 8, or in other words, it's the cube root of 8. Cube root of 8 is equivalent to the cube root of 2 times 2 times 2. 3 2's, so when they come out of that radical, it's a 2. So that's where this 2 comes from. It's the cube root of 8. Next, I'm going to write that important pattern that I've memorized. A cubed minus b cubed is a minus b times the quantity of a squared plus ab plus b squared. Now, for this example, a is going to substitute in with x, and we're going to substitute the b in with a 2. Do you see where those came from? A is replaced with x, and b is replaced with 2. So I'll go through my example. I could squeeze in this minus, plus, plus. The minus plus plus comes from same sign, opposite sign. Same sign is minus. Opposite sign is plus, and then always positive. So I could go through and put those, the subtraction and addition symbols in. And then I'm going to go in and I'm going to replace all of the a's with x's. So we have x, x squared, x, and then replace all the b's with 2. 2, 2, 2. And don't forget that the first and last term there, they're squared, right? Maybe I'll go back and highlight that a little bit more. That these are the parenthesis squared, right? Just from the pattern. Here it is, a squared, b squared. Well, this one does have a little simplifying. I don't want to leave this x times 2, and I don't want to leave this 2 squared. So the final factored example is going to be x minus 2 times x squared. I can drop those parentheses, plus 2x plus 2 squared is equal to 4. And there we have it. That's our finished example. Let's look at a couple more. When I look at number 5 on the next page here, x squared plus, or x cubed plus 27, looks like the cube root of x cubed is x, cube root of 27 is 3. Where'd the 3 come from? Cube root of 27. 27 is 3 times 3 times 3, so the cube root of 3 times 3 times 3 is 3. A cubed plus b cubed, that pattern factors out. I'm going to write the pattern a cubed plus b cubed is a plus b times a squared minus ab plus b squared. A is going to be substituted with x, and b is going to be substituted with 3. So I can go through, and for every b, I'll put a 3. And for every x, or for every a rather, I'll put an x. 3 x's, 3 b's. Can you go back in and fill in the signs? Same, opposite, always positive. Plus, minus, plus. And then the first and last term in that second factor is squared. I do need to simplify this slightly. So x plus 3. Could drop this extra parenthesis and just write this x squared minus 3x plus 9. Where'd the 9 come from? 3 squared. This next one is an interesting example. If I follow the steps, if I write the terms as perfect squares, that's easy enough. X squared is x, or the square root of x squared is x, and the square root of 4, 2 times 2, is 2. So I can write that out, but write the pattern. Well, which pattern is it? It's squares, so it can't be either of these two. But the problem is it's not this one either, because this is a sum. Which pattern out of the 3 does number 6 follow? None of them. Nope, can't do it. This doesn't match up to any of our factoring patterns. And you know what we'd say about this example? What we say about x squared plus 4 is that it's prime. It cannot be factored. Now, the only time that it could be factored is if there were a GCF, a greatest common factor, and there's not. We're going to see something similar with number 7, because when I break this up, we've got an x cubed, but then when I try to do the cube root of 16, problem is there's 4 2's. Now, if it was 8, that'd be doable, but the 16 doesn't give us a perfect cube, so we're going to leave this one as doesn't factor with into the types of numbers that we're working with yet. Don't let number 8 scare you, though. Number 8 is doable. We'll leave this one. We'll just say it's prime for now. But number 8, we can break this up because at 49, the square root of 49 is 7. So 49 can be written as 7 squared. And let me erase this to the right so that we have a little more space so I can show you what I'm going to do to this 1 over 36. Don't be afraid of a 1 over 36. You can do the square root of that because the square root of 1 over 36 is the square root of 1 over the square root of 36. Square root of 1 is 1. Square root of 36 is 6. Why is the square root of 36 6? Because 6 times 6 equals 36. So this 1 over 36 x squared is going to be, when I square root it, it's going to be 1 over 6 x. Or you could write it x over 6. So when I use the pattern that's going to fit is a plus b, a minus b. In this case, a is 7. B is x over 6 or 1/6 x, either way. Be careful here. When I fill these in, filling in the 7 is easy. Filling in the x over 6 or the 1/6 x is easy. But don't forget the plus or minus. So here we'll say 7 plus 1 over 6x times 7 minus 1 over 6x. Remember, we can change the order for that. And that's it. That's factored. That's all we've got. I hope you found this video helpful. And if you need to, review it a few times, pause it, and see if you can do the factoring on your own. Thanks for making time to watch this video.